So if you know how to do this, go ahead and start working on it. If you don't, you're waiting for it. I'll give you some hints, and maybe I'll let you try then a little bit later. The main thing here is that this is division. Okay. So give a real quick example here. If we had 1/2 divided by 3/4, what you do is, what do you do to that second fraction? We change it to multiplication, and then you flip the second fraction. And then when you multiply, it's nice because you multiply straight across. We're going to have 4. We're going to have 6, which is 2/3. Yeah? Okay? Apply that same idea here. We're going to be flipping that second fraction. Just write it right below it. And then what you can do is combine it all and then cancel out what you can. So I'm going to rewrite this here. X to the 5th y squared z times z squared on top, x squared y. So all it's doing is it flips the second fraction, and that allows it to change from division to multiplication. Yeah? All right. Now, just combine all those on one fraction and then start to reduce. And I will wait at this point to see how our reduction skills are. But most of this is stuff you've seen. And I'll even show a trick if you're like, I'm not sure how to reduce. There's a trick. With exponents, you can always do the expand method. So if you want to do the expand method, if you get confused, right? It looks like it's more work than it actually is to expand it. That's my expand method. All right. And once you have a final answer, check with your neighbor, someone around you that you can just check and maybe see if you got the same. But I like doing the expand method when I get confused because you don't have to know any of the rules. You expand it and it's just, right? If you didn't expand it, you'd have to remember, what is the rule again? X to the 5th divided by x squared. So expand it helps you actually understand and see what's happening instead of just like a rule like this. Because we're going to end up with, let's see, this is really what you get. X. Like mine usually look like these two. All right. X to the 3rd z. How'd that work out? Good? Okay, so a lot of this stuff, some of them you're like, yeah, that one, I know how to do that. That's pretty quick. So some of them are a little quicker than others. Some of them take a little bit more work. Like this one is going to be quick. And I really like when they're approachable like this. So solve 5 minus 3x is less than 20. Go ahead and solve it. Remember some rules. There might be some rules you have to keep in mind with inequalities. Okay, folks at home that might be a little bit confused about it. Let's see what we can do with this. Okay, start there. Get that going. This is really just a review of this rule that you're going to have to do. So Joshua, what do you have to think about when we divide by -3? Remember that one? What was the rule? It's something different. We got to switch. Oh, shoot. You want to phone a friend? Yeah. Who do you want to phone? Travis is the go-to.
Can I phone a friend?
Yeah. You can. Water bottle, what do we do? The answer would be negative. So -5, that is one element of this. What goes in between? That's what changes. Flip it. Flip it, right? Divide or multiply by negative, and it changes the direction of the inequality. Anybody say, oh, okay, we got a couple people, Dave at home. Perfect, perfect. I like that. That phone call went quick. Phone a friend, phone a friend, phone a friend. Phone the bottle, ask the bottle, get some insight. Okay, this is the main thing here, though. Divide or multiply by a negative with an inequality. You're going to switch the direction. Switch the direction of that inequality. That's what you have to do for this one. It's just a rule, right? So you can even put multiply or divide by negative. Switch the inequality. Oh. Okay. Have that rule there and handy for you. Boom. Okay. Yeah, let's do that one first. Let's do that one first. Okay, how about this guy? Huh. Whoops. It's 2. X to the 4th plus 1, that quantity, raised to the 2nd power. So you got to just remember anything squared is that same value or quantity. It's just it times itself. So I'm going to start you out just by getting it to this phase, and then you got to do one thing that we learned that, you can think of this as just distributing the x to the 4th to this expression, then it's distributing the 1 to this expression, just like in a long line. Or you can remember the word that might help you. FOIL. Okay, so we're going to multiply the first, the outer, inner, last, and see what you get. Okay. So first, and then outer, then inner, then last. You're just putting them all on one long line, long polynomial here. And if you're not sure how to combine them, like if you're like, I'm not sure, x to the 4th times x to the 4th, you can just put x to the 4th times x to the 4th, figure that out later. X to the 4th times 1 plus x to the 4th. So I've just done these. I just did the first two. Now go ahead and do the bottom two, and then we'll try to simplify those as we go. Ends up being a lot of x to the 4th in both. Okay. The bottom ones, we're going to go 1 times x to the 4th is x to the 4th. 1 times 1 is 1, so I just did these two. And now we're at the step where we can go in and try to deal with that first bit here. Now this is where if you're confused, you're like, I don't remember how to multiply those. No worries. Watch. Bring it over here, you say, well, it's really just x to the 4th. X times x times x times x. Right? Square times itself times another x times x times x times x. How many x's we got? How many? X to the 8. Right? So I always use, if you have a brain fart, you can't remember the rule for the exponent, just expand it. 8 x's in a row multiplied is x to the 8th. So now maybe even that helps you figure out, okay, when I multiply exponents the same base, I can just add the exponents. Get the rule from this, and it will start to come to you quicker. Let's see, x to the 4th plus x to the 4th plus 1. Combine these terms, and I think we're done. Okay. Remember, here we're adding them together. Before we were multiplying them, but here we're just adding them. X to the 8th plus 2 x to the 4th plus 1. All right. Okay. We're gonna go through them a little bit quicker. All right, guys. So I just wanna have these problems for you. When you get to these problems, you'll have something to review real quick. Okay, let's do this one real quick. And this is really good just because it's just solving for y. Let's go ahead and get that up there. And then the one thing that I want you to think about is x is connected to 5 by multiplication. X is connected to 2 by addition. X is connected to 6 by division. Now work from the outside in, from the furthest away from x. So we have to go after the 6 first. And it's going to be the same process for all of these. You're always doing the opposite to both sides. So instead of dividing by 6, go ahead and do something different to both sides. All right, instead of dividing, what's the opposite of divide? Multiply by what you want to get rid of. Both sides. So actually in this case, we're just solving for x. Y is still going to be in there. That's fine. Watch. By 6. You're gone. Now it's 6y is equal to 5x plus 2, and that's something we can work out pretty quick. Working from the outside in, instead of plus 2, minus 2. Let's do the opposite. 6y minus 2 is equal to 5x. So it's always just doing the opposite of both sides. That allows us to cancel them out. Plus 2 minus 2, 0. 6 divided by 6, 1. So that's how it's canceled. Now, last step. Divide it out, and we get x is equal to the 6y minus 2 over 5, and we're done. Beautiful. Let's see. All right, I'll do this one. So looking at this, if we're just evaluating this expression, it has some absolute value symbols in there. Now, if I said to evaluate, let's see, x is equal to negative 14. Evaluate just means plug in. Now, the only thing we got to remember, we're going to plug in, but we have to remember that there are absolute value symbols here. So go ahead and plug in negative 14 here for x, but then just be careful with those absolute values when you combine. Then remembering, what does absolute value do? It changes something. Every time it changes. And then check with your neighbor after you're done there. Essentially, we're just plugging in negative 14 plus 5. That's going to be absolute valued, and then divide by 3. So talk to your neighbor. What happened? What happened? Maybe check with Josh and Maggie back there real quick. You guys have an answer so far? Uh-oh. Not yet? All right, well, how about we combine negative 14 and 5, negative 9 over 3. And now you have to do the absolute value to that top part to get further along. All right, somebody at home, let me know when you get an answer as well. What do we end up with there? All right, Hunter, perfect. Got it. Okay. Maggie, did you get an answer? What'd you get? 3. Boom. Because the absolute value of negative 9 is positive 9. Perfect. And then we divide by 3. And we get 3. All right, nice, Hunter, as well. Perfect. All right, good online, good. All right. We didn't do too much with absolute value. There's no graphing. It's just the main idea, plugging in and dealing with this negative, changing it to be positive. Let's keep on going. How about this? 2x plus 2. Okay, what's a strategy we can have for this one? What do you think? Anytime you have two fractions equal to each other, proportion like that, what can we do to make it a little easier for us? Not sure. There's a bunch of ways to approach it. I mean, there's one that I think of as one of my favorite things because it gets rid of both the fractions. Remember this? Okay. So if that gives you enough of a hint, then go ahead and multiply those quantities in that way. It's basically going to multiply x plus 2 times 1, 2 times x, and it allows us to get rid of see, it gets rid of the fractions. So it's just cross multiplying. Maybe even make a note of that so you can remember cross multiply. Okay. This reduces pretty fast. And check with your neighbor when you get the answer. You could show them on one hand what their answer is. Remember, the goal is when you have variables on both sides, you want to get them all to one side. So keeping them positive, it's going to mean I need to subtract this x over to this side. If you subtracted the 2x, you'd end up with a negative x. That's not super helpful. So if I do this, I end up with 2. And look, right away, I got my x. Easy. Okay. Okay. Everything so far are mostly things we've touched on in the long year. This one, we did not touch too much. 75. So we need to reduce this. We need to reduce the square root of 75. Let's see about that. Okay. This might be kind of hard. Because first off, the goal is this is square root. So we're trying to break it into pieces that we can take the exact square root for. Okay. So what is a factor of 75 that could be a perfect square that we'd be able to square root? What do you think? All right, good at home. We have 3 times 25. Square root of 25 we can actually take. That's going to be helpful in the moment here. So you see, once you split it up within the radical, then you can go in and divide them out into two different radicals. So we can make our final bit right here. Because we know that. What's square root of 25? So watch. I'm going to rewrite this, and we typically put the number that is the whole number on the outside over there. There we go. That's my final. Okay. I'm going to try another one with you. How about this? Square root of 45. Go ahead and do it. Now that you know the rules and the things you could do, go ahead and split it up first. Square root of 45. And start to think, well, what is a perfect square that's involved in that? 45. What are my factors for 45? All right, somebody at home, let me know what are the two numbers you can factor 45 into that are going to be helpful, because you can break it up however you want. But what's one at home? Somebody at home? Nice, Hunter. Anyone else got an idea at home? Yep. All right, how about in here? 5 times 9? Okay. We could then break it up. And again, the goal is to get here. The goal is to get where one of them is going to be a perfect square. So if we have a perfect square, we can actually do that work and have 3 root 5 as a final. Okay. So we didn't see too many of those, actually. I only have one more that I want to do today. Yeah, I'm going to do this one. Yeah, I'll do this. Okay. Yeah, let's do that. The last one. Give you a little time. Ooh, painful. Sorry. All right, number 10. Halfway there. I want everyone to draw a triangle, a right triangle. Okay. And as well as you can, I want you to make a box that extends out, a square that extends out from each side. So the distance of this length here has to be approximately that distance in order to make a square. Right? This distance here is the side on this side. It goes off the page, but you can see we got another square here. Here is the pieces of information that we have. We're trying to find this fluorescent side here. We know that the boxes, the squares, this one is 3 feet square. This one is 25 feet square. And we're going to use that information to try to figure out, maybe we could figure out the side lengths and then figure out what x is. So I really want you to try to think about this one for a little bit. If we have the area of one square is 9, then what is the side? So think about that. That's a hint for that. If the area is 25 feet squared, what is the side? That's enough. Plus this. That is enough to figure out what x is. Okay, so I'm going to give that as like the final one here. I want you to check with your neighbors, and let's see if we can figure out what x is. I'll go and work this out like in a few minutes. I'm going to give you a few minutes for this. So essentially, you could think of them as separate parts. You could say, well, I have the square here that's 9 is the area, 9 feet squared. So it's just trying to figure out, well, I know that the sides of a square are exactly the same. So what is each of that side going to be? It's going to be the square rooted of it. So it's 3 and 3, right? That's the key, okay? So now work your way through the other bits and try to figure out what the x is. That's the last hint. the last hint. All right, and check their neighbor if you know it in the class. Then we'll try to work our way through it. We kind of deduced right now that this was a 3 by 3. So I know this side right here is 3. So what about this 25? What's that going to be? A what by what? Um, so remember that the sides of a square multiply to give you what's in the middle. So 3 times 3 gives you 9. How about what times what gives you 25? 5 by 5? 5 by 5. So now we know essentially what we're working with is a side we don't know, hypotenuse of 5, side of 3. So go ahead, and now we're using this here to figure out what x is. No problem. No problem. All right. Yeah. Keep working your way through that. One step away. One step. So we get x is 4. Good. Who got 4 in here? You get 4? Yeah. Yeah. Getting 4. Getting there. Okay. So this is just using Pythagorean. It's the type of problem you'll see on these kind of tests. The key is that really just think about if they give you the area, you're dealing with a square where the sides are the same. So this is 3 times 3, 5 times 5. And from that, we have the sides of the triangle to work it out and get the extra side. And that's it. That's it. Okay. I think that's actually the maximum bit of like random problems we can do in one day. So I'm going to stop. That was a good 10 problems.